Good morning, business algebra. So 6.3 is word problems that go with the systems of equations we've already done. So conceptually, it shouldn't be anything new, but I do want to make sure we do some of those. I'm going to do problem number 1 and set up problem number 2 so that you have an idea of how they work. Okay, so problem number 1 says a rent-a-truck company is buying new vans, small trucks, and large trucks. Each van costs $25,000, small truck $30,000, large truck $40,000. The company needs twice as many vans as small trucks and wants to spend $5 million, but only needs 175 vehicles. How many of each kind should it buy? So we've got some relationships here. The total cost, the total number of vehicles, and they need twice as many vans as small trucks. That's three relationships with three unknowns. Then we need to turn them into equations. So we're going to let X be the vans, Y will be the small trucks, and Z will be the large trucks. Now, let's use this. We know that the cost is $25,000 for a van, plus $30,000 for a small truck, plus $40,000 for a large truck, and they're spending $5 million. And yes, we'll get rid of the zeros in a bit. We know the total number of vehicles, X plus Y plus Z, is supposed to be 175. And our last thing is the company needs twice as many vans as small trucks. So that means X is equal to 2Y, because the number of vans is equal to 2 times the number of small trucks. So let's break this down. I'm going to move everything to the left side so our constants are over here, so I'm going to subtract the 2Y. I can get rid of quite a few numbers here. I'm at least for now going to divide by 1,000. We'll divide again in a second. So 25x plus 30y plus 40z equals 5,000. Got rid of 3 zeros. Now I can go further than that because these are all multiples of 5. So that would be 5x plus 6y plus 8z equals 1,000. So that's my first equation, fully simplified. Second one is x plus y plus z equals 175. And the last one is x minus 2y equals 0. By subtracting the 2y to the other side. This is a system. My suggestion to you is, if there's ever a missing variable, I already have an equation with just x and y. It would be nice if I could get another equation with just x and y. And to do this, I'm going to combine the first two equations, but I'm going to have to multiply this equation 2, by -8 so that the z's will cancel. So -8 times 2 is -8x minus 8y minus 8z equals -1,400. I'm going to pair it with equation 1, which is 5x plus 6y plus 8z equals 1,000. Now, when I add these two together, I get -3x minus 2y, z's are gone, equals -400, which I can then use, I'll call this equation 4, to combine with my equation 3. Now, the nice thing about that is I'm going to change this to all positive, so 3x plus 2y equals positive 400, just by changing all the signs, because they were all negative. But really, it's mostly to get my negative 2y and positive 2y to conveniently line up. So x minus 2y equals 0, then 3x plus 2y equals 400. Now that my y's will cancel out, I can add these two together. So I get, that's 3 plus 4. I add these two together and I get 4x equals 400, a nice round number. So what does that mean? X is 100. That means we want to buy 100 vans when we get there. But I can use this to plug in to find other equations. First off, up here I see that x equals 2y, which was this equation down here. from the very beginning, x equals 2y, or x minus 2y equals 0. So I can say 100 minus 2y equals 0. So 100 equals 2y. That makes y 50. So I've got 100 vans and 50 small trucks. Lastly, my original equation up here, number 2, x plus y plus z equals 175. Substitute in 100 plus 50 plus z equals 175. That's 150 plus z equals 175. So z is 25. Now, what does this mean? It means they want to buy X is again vans, so 100 vans, 50 small trucks, and 25 large trucks. So this is how you solve one of these word problems. And then the answer should be in words. Don't just leave it as X, Y, and Z. Just write out what it is. It's a word problem. Now let's set up number 2. It says tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. 570 people attended the concert, and the total cost of the tickets was $19.50. 3/4 as many teenagers attended as preteens. How many of each group attended the concert? So we've got price, we've got attendees, those are relationships, and we've got the ratio of teenagers to preteens. Those are our 3 relationships. So I'm going to let X be adults, Y be teens, and Z be preteens. So let's talk about the price. Every adult paid $5, teenagers $3, and preteens $2. So 5X plus 3Y plus 2Z equals the total price for the concert, which was $19.50. Also, we know the total number of attendees was 570, so that's just X plus Y plus Z, because everyone counts as one attendee. Some people may think they're the center of the universe, but in fact they are still just one person. And it says 3/4 as many teenagers attended as preteens. So that means the number of teenagers, Y, was equal to 3/4 the number of preteens, Z. If you want to convert that into whole numbers, you can multiply both sides by 4, so that 4y equals 3z. Some people will find that easier to work with in the system than the fraction. So you can use those equations to find your answers, and the rest of them are similar. The last one can be a little bit tricky, but overall it's not too bad. This is all we're going to do for today, so I hope this is helpful, and if you have questions, of course, you can always send me an email. Thanks, and have a nice day.